Hi friends, good morning. Previous class, we have discussed question number 14. It was not finished. So today once again we will discuss that. Question number 14. Exercise 6.1. Question number 14. Sand is pouring from a pipe. From a pipe at the rate of 12 centimeter cube per second. Okay, the sand is falling from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground. The falling sand forms a cone on the ground like this. Okay. Now, in such a way that the height of the cone, let height of the cone is h. Base radius of the cone is r. Height of the cone h equal to 1/6 of the radius of the base. H is equal to r by 6 given. Then how fast the height of the sand cone increasing? When the height is given h equal to 4 centimeter, then what is the rate of height? Rate of height is dh by dt. Okay, so given here, sand is falling from a pipe at a rate of 12 centimeter cube per second means what is this? The volume of cone dv by dt. The rate of volume of cone or sand forming like a cone, which is equal to dB by dt equal to 12 centimeter cube per second. Next, height of the cone h equal to 4 centimeter. Height of the cone. Given condition, height of the cone equal to 1/6 of the radius, base radius. R is equal to base radius. So R equal to 6h. The equation 1. What is the use of this? To make the, if there are two variables, we can convert it to single variable. Okay. What is the volume of cone? Volume of cone B equal to 1/3 pi r square h. Here there are two variables, R and h. There are two variables. So we have to make it single variable. Okay. So to make the single variable, use this condition. That's why they give a condition. Are you following? So otherwise you will get dr by dt and dh by dt. Both will get. When you apply differentiate here, u into v, both are variable here. R square and h. R square, h derivative is dh by dt plus h into r square derivative is 2r into dr by dt. But they are not given dr by dt. Okay. So what we are going to find height of the cone is dh by dt. So dh by dt, to find that r we should eliminate. To eliminate r, use this condition, r equals 6h. For that reason they give r equals 6h. V equal to 1/3 pi r 6h whole square into h. V equal to pi by 3, 6 square is 36, h square into h is h cube. This get cancelled. So V equal to 12 pi h cube. V equal to 12 pi h cube. Now we should apply differentiate with respect of the dV by dt equal to 12 pi constant d by dt of h cube. 12 pi h cube differentiation 3h square into h differentiation with respect of t is dh by dt. So which is equal to 12 pi into 3 h, where h is equal to 4 centimeters, 4 square into dh by dt we don't know. Let us find dv by dt given 12. This get cancelled. So 1/3 pi into 4 square 16 equal to dh by dt. Therefore dh by dt equal to 1 by 48 pi centimeter per second. So the rate of height of the cone, the sand falling on the ground to form a cone, the rate of the height of the cone is 1 by 48 pi centimeter per second. Conclusion, you can write it, rate of the height of the cone, or rate of the height of the sand falling on the ground at the rate is 1 by 48 pi into centimeter per second. Most important is question number 15. The total cost C of x in rupees associated with the production of x units of an item given by C of x equal to 0.007 x cubed minus 0.003 x squared plus 15x plus 4000. Find the marginal cost when 17 units are produced. Find the marginal cost when 70 units are produced. 70 units are produced. What is the marginal cost? They given the cost, total cost, C of x given. Yes, marginal cost means MC is representing marginal cost, short form of that. Marginal cost means rate of change of total cost with respect production. Rate of change of total cost with respect production. This is rate of change of total cost with respect to production. Here production x units. Total cost is C of x. So that means the marginal cost equal to rate means D of change of total cost means total cost represented by C of x. DC by production x dx. Here dy by dx. Y is nothing but total cost. X means production. So marginal cost dc by d, short form is dc by dx. C is in terms of x. Let's find dc by dx. Here marginal cost equal to dc by dx. This is C with respect of x. Okay, here d by dx of C 0.007 x cube minus 0.003 x square plus 15x plus 4000. Okay. Now 0.007 into x cube differentiation is 3x square minus 0.003 into x square differentiation is 2x plus 15x derivative is 15. 4000 difference is 0. Constant. This is marginal cost. At x is equal to, when x is equal to 17. At x equal to 17, the marginal cost is MC. MC is not equal to marginal cost. 0.007 into 3 into x equal to 17 square minus 0.003 into 2 into 17 means 34 it is plus 50. This you simplify, aggregate, you will get the value, that is the marginal cost of it. Do yourself. Okay, after calculating you will get this marginal cost 20.967 h, x is equal to 70. Question number 60. The total revenue in rupees. The total revenue in rupees received from the sale of X units of a product. If a product is R of X equal to 13x square plus 26x plus 50. Find the marginal revenue. Find the marginal revenue when x is equal to 7. X is equal to 7. Find the marginal revenue when x is equal to 7. See, here marginal revenue means the short form of that amount. Rate of change of revenue, total revenue with respect sale. Here sale represents x units and total revenue is R of X. So dr of x by dx, that is marginal revenue. The marginal revenue equal d by dx of R of X, 13x square plus 26x plus 50. 13x square differentiation is 26x plus 26. The differentiation is 0. It is marginal revenue. X is equal to 7. At x equal to 7, the marginal revenue equal to 26 into 7 plus 26. 26 take common, x 7 plus 1. So 26 into 8. How much? 208. 17. The rate of change of area of circle. The rate of change of area of circle with respect to its radius. With respect its radius. R equal to 6 centimeter. At R equal to 6 centimeter is, it's the option, objective question is, you will ask in CET. B option is 12 pi, C option is 8 pi, T option is 11 pi. The rate of change of area of circle with respect of radius. Area of circle is formula pi r square. We should find dA by, not dt, with respect of radius, dr. Okay, so pi is constant, d by dr of r square. Pi into r square differentiation is 2r. R derivative with respect of r is 1. So 2 pi r equal to 6. So which is equal to 12 pi centimeters per second. This is the option. And in this topic, the exercise is over. And 18th question, you can find try yourself because they ask the marginal revenue. Just now I said marginal revenue means the rate of change of total revenue with respect of sale is called marginal revenue. You try question number 18 and example. So I will explain example 2. Example 2 I will explain. Example 1 homework. Example 1 and 3. 4 I think done. Example 4. 5, 6. This is the homework. Example 1, 3, 5, 6. Second I will explain. Second, which is important, you will ask it many times. Example 2, which is important, 5 marks question. In this topic, 5 marks question, most important. Example 2. Example 2, 3, 4. This topic. Example 2, 3, 4. And exercise 6.1. In that, 5 marks questions are 4, 5, 4th question, 5th question, 7, 6 times 7, 8, 9, 10, 8, 9, 10, 11, 12, up to 14. From 5 to 14. From 4 to 14. These are 5 marks questions. Most important. Understood? So anyone guarantee? These are 3 questions, 2, 3, 4, and 4 to 4 means 10. 10 plus 6, 13. Out of 13, anyone 5 marks question guarantee. Now, the example 2, the value of Q, is increasing at the rate of 9 cc per second. 9 cc per second. Okay, that means the value of Q is increasing at the rate of 9 cc per second means dV by dt. Let V is the value of Q. dV by dt equal to 9 cc per second. Q. That is edge of the cube is x. Now, how fast the surface area increasing when the length of edge is 10 centimeter? Edge given, edge of cube, x is equal to 10 centimeter. Right? How fast the surface area? Surface area formula, surface area of cube 6x. Okay. Now, see, surface area of cube equal to S. The name surface area. S stands for surface area of cube. S is equal to 6x square. Now we are going to find area of surface area, means ds by dt. How fast the surface area ds by dt equal to 6 into d by dt of x square. d by dt of x square. So 6 into x square differentiation is 2x into x differentiation with respect of t dx by dt. Okay, 6 into 2, 12x, where x is equal to 10 into dx by dt and ds by dt. See, 12 into 10, 120. ds by dt equal to 120 into dx by dt. Yes, this is equation 1. But dx by dt given? No, they given dv by dt. So let's find this dv by dt given, but not ds by dt. Here there are two unknowns, ds by dt and dx by dt. So how we can find dx by dt? Then value of q. What they are given? Value of rate of value. So let's use the value of q formula. So value of q, v equal to x cube. So dv by dt equal to x cube differentiation with respect of time 3x square into dx by dt. Now dv by dt 9, 3, x is equal to 10, 10 square is 100 into dx by dt. This get cancelled. So dx by dt equal to 3 by 100 centimeter per second. So this is, substitute here, will get ds by dt. From 1, ds by dt equal to 120 into dx by dt, 3 by 100. Okay, this gets cancelled. 2 5 there, 2 6 equal to 18 by 5. 18 by 5 centimeter square per second. That is rate of area of surface area of cube is 18 by 5 centimeters square per second. This is important and 5 marks question. Okay. So far we have discussed rate of change of quantities. Okay. dy by dx meaning is derivative of y with respect of x. dy by dt meaning is derivative of y with respect of time. Okay. ds by, okay, so rate of change of quantities with respect of other quantities we have discussed so far. Now we will discuss the next application of derivative, increasing and decreasing function. Increasing function. Okay, increasing function means, for example, here x o x dash, y o y dash. There is a function y equal to f of x. Here 2 points here x1 and x2. The graph is like this. This is y equal to f of x graph. At x1, this length how much? This length is how much? F of x1. This domain x1 substitute in this will get range. This is y. x2, at x2, what is the range of this? What is the y value? F of x2. Okay, you see this picture x1 and x2. What is the relation between them is x1 less than x2. x1 less than x2, increasing this. As x increases, then f of x1, what is the relation between f of x1 and f of x2? Less than. This is small and this is big. If x1 less than x2, then f of x1 less than f of x2 for all x1 comma x2 belongs to I, where I is the domain of f of x. Where I is the domain of f of x. Then the function is increasing, strictly increasing. One more graph I will have here. xo x dash, yo y dash. Here x1, here x2. See, here x1, this length is f of x1, this length is f of x2. x1 less than x2, then f of x1 and f of x2 relation, small and big, okay, less than. But I said x1 and x2 belongs to the whole domain. If I take x1 here, x1. Here x2 I am taking. So here f of x1 and f of x2 both are equal. Okay, that means if x1 less than x2, then f of x1 may be equal also in this case. F of x1 less than or equal to f of x2. For all x1 comma x2 belongs to I, where I is the domain of f of x. Then this function is said to be increasing function. This is called increasing. Here no equal here, no r equal. This is called strictly increasing function. Strictly increasing function. Are you following? This is called strictly. A function f is said to be strictly increasing function if x1 less than x2, then f of x1 less than f of x2 for all x1 comma x2 belongs to I. Next, a function which is said to be increasing function if x1 less than x2, then f of x1 less than or equal to f of x2 for all x1 comma x2 belongs to I. So this is increasing strictly and this is increasing function. The difference understood? Strictly increasing and increasing. In increasing, sometimes both may be equal, f of x1 and f of x2. But in strictly increasing, never f of x1 and f of x2 not increases. Means not equal. Increasing but not equal. Strictly decreasing function. Strictly decreasing function. xo x dash yo y dash. x1 this is, let this point is x2. x1 less than x2. This length is f of x1 and this length is f of x2. So what is the relation between these two? F of x1 is greater than f of x2. For all x1 comma x2 belongs to I, where I is the domain of the function. F is said to be strictly decreasing function if x1 less than x2, then f of x1 greater than f of x2. For all x1 comma x2 belongs to I. Strictly decreasing. Next, decreasing function. Decreasing function. See, xo x dash yo y dash. Like this. Here x1, that is point. This is x2. Okay. x1, at x1, what is the range of this one? F of x1. At x2, this range is f of x2. Okay. If x1 less than x2, tell me f of x1 and f of x2, relation between them, greater than. But in this case, both may be equal. Both may be equal. So f of x1 greater than or equal to f of x2. For all x1 comma x2 belongs to